Okay, welcome to the second video of Chapter 6, where we're going to go over line equation analysis. We have two different types, a high-low method and a regression analysis. Let's go ahead and get started. So this is going to cover learning objectives 6.4 and 6.5. We'll spend most of the time on the high-low methods, and then we'll take a quick look at regression analysis. The regression analysis is mostly just kind of introduction to the concepts. So with high-low method, if you remember, we talked a little bit about, let's get this set up. We talked a little bit about how the various fixed costs and the variable costs look like on a graph. Well, we're going to use that same sort of thinking and look at graphs again and kind of use those for our method. So high-low method is, let's say you don't know the exact amount of your variable costs and you don't know the exact amount of your fixed costs. And that's very common. A lot of times a cost accountant will come into a business and they'll just say, here's a bunch of information from prior periods, just figure it out. And typically the two things that you have from prior work periods is how much you produce, so the volume or the production or the number of units, and how much your costs were. And from this bunch of data, you're going to try and figure out what were your fixed costs, what were your fixed costs, and what were your variable costs. What were these two costs? And so I've left a few dashed lines just to kind of represent, these are other numbers, but for our purposes, we're just going to focus on a couple of numbers right now. So when we do high-low method analysis, you're going to have a graph, you're going to take these and you're going to say, okay, the volume, that's the activity. This is going to be your x-axis, and your costs are going to be your y-axis. And why we say that is we say the x-axis is the thing that determines the y-axis. Your volume is what determines your costs. So if we looked here on the graph, we would say this would be the x-axis, and this would be the amount of units, and this would be the y-axis, and this would be the dollar amount. So we might go through and maybe we have a whole bunch of data and we would plot it out. So the basics of high-low method analysis is to not look at all of the data, but look at two representative points of the data. And what we look at is we look at the high volume and we look at the low volume. And then we go and we take the corresponding cost. Now this is important because if you notice, we did have a cost here that was higher, but the volume was in the middle. This volume was in the middle. So it's not that you pick the high Y and the low Y and the high X and the low X. You pick the high X. You focus on the X. You focus on the volume or the activity. This is the one you focus on. And then you take the corresponding number. In other words, these are all points on the graph. You can't mix and match. You can't say, oh, I'm going to take the X value for this and the Y value for that one. So for example, here on the graph, maybe there's a whole bunch of points. Maybe there's points here, points whatever. Maybe there's a point here. The point is that you're going to take the high X and the low X. So you're going to take this point and this point. And even though that there might be lower Ys, those don't correspond to the same point. And what we're going to do is we're going to find a line between these 2 points, and we're going to call that our line equation. That's our high-low method analysis. It's a rather basic one. It's assuming that your costs are rather linear rather than curved or something like that, but it's a basic sort of introductory thing. So how do we do that? Well, if you know kind of your line equation, you can say it in a lot of different ways, but a lot of times we say y equals ax plus b. Sometimes it's mx plus b, sometimes it's mx plus f. It's a lot of different things. What we want to know is this is our costs. This y is our costs. This is going to be the volume. This is going to be our variable cost rate. And this is going to be our fixed cost. So from a whole bunch of data, we can figure out this equation. And that will allow us to predict future periods. So if your boss came and said, I've got a bunch of data, but can you tell me what you think our cost would be at like a 50 volume? Well, you may not have something that's close to 50, but you can still predict the cost. Well, what we're going to do is basically figure out what's going to be the change in the slope of the line, which is the change in y over the change in x, and we will come up with a whole equation. So we're gonna rather than do that here, we're going to actually look at we're going to look at it in a problem. Just remember that we're going to focus on the high and the low x and take the representing costs that go along with it, and then work out an equation, and we're going to end up with something like this in each situation. So let's take a look at the first homework problem. So here in the one that's similar to question number 6, they don't give you a whole bunch of data. They just give you the high and the low. This one's going to be the low, and this one's going to be the high. And when we look at question 7, it's going to give us a list of data like I gave you. So just realize they can give you 2 points of data that represent the high and the low, or they can give you a bunch of data, and you've got to figure out what it is. So we first find out, well, what is the high and the low volume? Well, they only given us 2, so we're just going to plug in the numbers that they've given us. So it's 960, pardon my handwriting, 860, and that's going to be the change is 100. The high cost, well, this is going to be the 27,800, and this is going to be 25,600, and the change in cost is going to be 2,200. And so you would take, remember, this is going to be the y, the cost, and this is going to be the x. So we take the change in y, this is the change in y, divided by the change in x. So we would take 2,200 divided by 100, and what does that come up with? Well, that comes up $22. So what this represents is for every change, every extra unit we make, or every, whatever the cost driver is, every hour that we work, we add on an extra $22 in overhead of the variable. So just like I say, we need to make this into an equation to allow us to predict other types of volume. Well, this right here, that's our 22. Well, this is the next thing we need to figure out. So if this is our variable cost, we need to now figure out what is our fixed cost. Well, how do we figure this out? Well, the thing is it doesn't matter which one of the ones you use. You can use the high or the low, but what you're going to do is you're going to plug in 2 of the known numbers that you have into the equation and solve for B. So you could plug in 27,800 and 960, or you could plug in the 25,600 and 860. Because what we found out was on this line, it's going to work for either one. So use either one. It doesn't matter. I'm just going to use the high right now, the 27,800 equals, so that's the y, equals the rate times, and what was the amount of hours? 960. And so when we back figure this out, when we go ahead and solve it, well, this is still going to be 27,800. 22 times 960, well, I've already figured that out. It's going to be 21,120. And what we do is we just move the 2120 over to the other side. So just solving for B is going to be the 27,800 minus the 21,120. And what that says is 6,680. So if you remember, this is the $22. That's our variable cost. If you remember our 2, and this is going to be our fixed cost. If you remember that little graph that we looked at mixed costs, remember the mixed costs were, we had a dashed line here that represented what the fixed cost line is. Well, that's the 6680. And then we have a sloping line, and that represents the slope of that line is 22, or in other words, in every unit you go over on X, you go up 22 on Y. So we call this the fixed cost, but in line equations, we also call it the intercept. So we can create a little line equation down here, which I have in green. All it is, okay, here's the rate times whatever volume you want to come up with. This is an unknown, right? This is an unknown. And then add 6680. So if your boss came in and said, well, how much would it be for 150, or how much would it be for, 32 or whatever. You could solve for how much does it cost by just plugging in what's the new volume. And in fact, the second part of the question asks just that. So it says, what is the expected cost for 885 hours work? Okay, that's right. So I'm looking at the wrong numbers, but 960, because I was thinking about my original one. So the volumes here were 860 and 960, and they said, well, how about somewhere in the middle, 885? Well, you could guesstimate, but now you have this equation. So you would just solve it by plugging in, okay, if you want to know the new cost, it's 22 times, well, it's this 885, that's the volume, plus 6680. You would solve that out, and you would tell your boss that your estimated expected costs would be this. So let's go down to question 7. Now this is going to be almost exactly the same. The only additional thing that they're testing is what I kind of went over initially on high-low analysis. The idea is, okay, rather than just giving you the high and low point, which they did in question 6, can we pick it out? Which one is the high? And which one is the low? Well, remember, cost is going to be, almost always is going to be our y, and our activity or volume or amount is going to be on the x-axis. We're going to look for the high and low x. So which one is the high and low x here? Well, we can see that it looks like it's going to be, the low is this one, and this one is the high. Now you notice if we go over here, this y is actually a little higher. But we are not interested in it because we're going to take whatever the high and low x is and its associated y. So we would say, yeah, I see that that is a number that's higher than this, but that's not the one we're worried about. We focus on the x high and low, and then we take because remember, this is a point, right? This is a point on a graph. And so we would take 1080 as our low, and we would take this number, even though this may be a little lower, we're not interested in it. We're interested in the high and low x and its associated y. So same thing, we're just going to go through and plug those in to get our rate or our slope of our line. So we plug in, what is it, 1480 minus 1080, and that's going to be 400. And our high cost is going to be 4192 minus 3532. And that's going to be 660. So the change in costs, 660 divided by 400 equals $1.65. So every additional machine hour results in another $1.65 of variable costs. Okay, so just like we did in the previous equation, it's wanting to know, okay, now that we've figured out this, now that we've figured out the slope of the line, in other words, we figured out this. We figured out what's the slope, but where does it cross? In other words, where is the fixed cost point? So we would plug those in. So this is just pulling out those information that we had before. So like I say, you could take the high or the low. This just happens to be the high again. So we would say, okay, the high cost, and this is the rate that we just figured out from the previous page. So the high cost is $41.92. We figured out this rate of $1.65. The volume is, this is the volume, 1480. And we would just solve. We would just solve for B. And it just so happens if we go through the process of solving for B, we get 4192. When we multiply those out, that ends up being 2442. This one I'm not doing in my head. I'm actually cheating off my previous calculation. That comes to when we then move the equation around and solve for b, which is our fixed cost, 4192 minus this 2442 equals, and this is our fixed cost. So when we have our equation, we already have figured out the variable cost. That's the variable cost, the 165. And now we just pull this down. This is our fixed cost. And that's our equation. So when the third part of the question asks, okay, and if you notice, this is exactly the same one, figure out your cost equation and then give me a cost for a new volume. So we would just take this previous equation and we'd say 165 times the new volume, which is 1210, plus 1750. And then we would say our new cost, when you go through and solve it all out, comes out to 3747. So you take a high and low point. You use those to figure out your variable costs. You plug in either the high or low again to figure out your fixed cost. You then come up with the cost equation, and then you can use the cost equation for new values of x to figure out your new costs. So if you notice in the high-low, we're just using 2 points. So let's take a look at I don't know how all of these little dots get here. Take a look at a regression analysis. Now, it may seem scary at first, but let's just talk about what it's representing. Like I said, in the high-low, we're just taking 2 points. We're taking a kind of arbitrary high and low point, ones that we select. What the regression analysis does is the computer actually takes all the points and figures out the best line that that most matches in between all of them, rather than the high and the low point. We're just hoping that the high and the low point is the best match. But when you feed all the data into a computer and do regression, it will give you a whole big output like this. And in fact, it can give you a whole lot more. But we're focusing on these three things, the R-square and the coefficients. So all we really need to know is the R-square tells us something about how good the regression is, and these two values are, remember the intercept, that's our fixed cost, and the variable, x variable, is our variable cost. Because remember the intercept, when we were saying before, that's where this line crosses 0. In other words, that's our fixed cost line. If we had 0 production, we still had to pay the rent. So those are the three numbers. So we can just take those numbers and really plug them in right away. So if we looked at this, our cost equation, we could take from this is 6.84, which is just the x variable. And if you notice, it's paired with the x. That's one way you can tell. And the intercept, I think you just have to remember the intercept is if there's 0 production, where does the line cross? That's how much your fixed costs are. And here, so depending upon the question, it may say round off to the nearest dollar or to the nearest cents. So if it was to the nearest cents, this would be 318,794. And I will just kind of look at here at requirement number 3. In question number 8, it does say determine its cost with a new volume. And I won't actually do it because you have the equation. All you have to do is take this cost equation, plug in the new volume, multiply it out, and you'll get the answer. Now, requirement number 2 asks you to understand a little bit about the output and this R squared. Now, the R squared is 0.77. You'll see here I have it highlighted. And what does that indicate? Well, I guess the best way to explain it is how close are all the dots clustered around the line. If they're clustered pretty close to the line, in other words, the line is actually right in the center and the dots aren't too far away, then you'll get a higher number. If they're all right on the line, then you have kind of an r squared of 1. If they're really random, in other words, the line isn't telling the full story, there's something else going on, then you would have a lower number. So it kind of indicates how well does the line describe what's going on. And it says it's giving you kind of a percentage. It's saying it describes about 77% of what's going on. Now, I noticed that in the book, it actually says, the question says for here, 77%, it should be used with caution because the company may or may not feel comfortable, may not feel confident using it. Actually, in a lot of statistical studies, 77% actually, that's obviously, it's describing more than half of what's going on. In fact, it's describing more than 3/4 of what's going on. So perhaps for industrial things, you may want, production things, you may want it to be higher, but just in general, if you felt like, well, 77% seems like high, that's actually a pretty good r squared. And if I was even a cost accountant and a statistics guy in the cost accounting department, I'd probably say, that's still pretty good. That kind of gives us a really good picture. So I'm just throwing this out here that you may or may not encounter this in your own question. In other words, I wouldn't know if I would say it should be used with caution, but the problem might say that. So just be aware that they're probably looking for a much higher r squared. But I still think that as long as you understand what's the general thing of it, just kind of plug away and figure out what the question's asking. Okay, well, thank you. That's all for this. Once again, if you have any questions, feel free to email me or show up for the online Zoom, which is shown on Blackboard. And I will be putting out the third one of the video series soon, the third one of this chapter soon. Now, I did mention I was going to do one for the quiz, and I'm not sure about the format about that yet, but I will figure that out in the next couple of days and do something for that. Okay, thank you.